Hi everyone, this is going to be the virtual session for Module 7, the beginning portion of it. At this point you should have already completed a few lessons and you should be ready for the mid-module check. Hopefully this will give you a good review of all that you've learned so far. Please have out a piece of paper so that you can take notes as we go, or also to just write out problems. You may pause the video at any time and do the problems on your own and then unpause to check them. This first page right here is the reflection sheet that you'll need to either print out and write on, or just write onto it into a Word document or in a PowerPoint somehow, type into it. So for the topic today, we're going to be going over the number line and rational numbers and using integers. So you can put that on the topic. There are going to be 3 problems that we're going to do throughout this. You're going to put the example problems in this dark blue square, and then you're going to solve it in the lighter blue square, and then put the answer in the lightest blue square at the bottom there. And I will have 3 problems that will be noted to go in there. All right, we're going to start with these number lines here. This actually came right from a lesson. I just want to kind of go over it to re-explain it. So at this point, you should probably have already seen this before, but let's go over them just as a review. If you'd like to pause it right now and try to answer this question, you could do that. All right, so this one right here says -4 plus -3. So we're just going to show how you would put these on a number line. All of these are going to start at 0. And the first thing says to go to -4. So we want to start at 0 and go to -4. These two right here both go to -4 right away. See, the red line is going to that -4. The second part of the equation, though, says to go -3. Anytime we have a negative or a minus, we're going to go to the left of the number line. If we have a plus or nothing, that just automatically means it is a plus sign, then we're going to go to the right on the number line. So the next thing says plus -3. So this one right here, we're going to go back 3. 1, 2, 3. So this first expression will go with this third line right here. Let me clear that off and I'll do the next one. The next one says 4 plus 3. I mean, obviously, at this point, you probably shouldn't need a number line to tell you what 4 plus 3 is, but to show it, to model it, we're going to start at the 0. We're going to go up to the 4. Both these two right here go up to the 4 to start, but then it says plus 3. So remember, when we have a plus, we're going to go to the right, so we're going to go 1, 2, 3. So that expression would go to this one here. The next expression, -4 plus 3. Again, we're going to start at the 0. We're going to go to the -4, so both of these would be that. And then plus 3 means we're going to go to the right 3. So 1, 2, 3. So that expression would go with this one. And then last but not least, this expression here, we have a +4. So we went from here up to the 4. And then we're going to go back 3. We have to go back to the left 3. So 1, 2, 3. The answer to these expressions are where you end on the number line. So the answer to this expression would be a +1. The answer to this expression would end on a -4. So that's just a way to use number lines to explain how you get the answer there. I'll give you another way in just a little bit. All right, so here is your first example, or your first one that you're going to put on your reflection sheet. So go ahead and write out the problem. It says rewrite 7 minus 8 using the additive inverse. So you can kind of write that just in that little part, and then we're gonna draw the number line in the part where you're explaining how to do it, and then I'll show you what to put in the answer thing. Okay, so we're starting at a +7. When there's nothing in front of the 7, that means that it's positive. So we're gonna start at the 0 and go up to 7. So all of these lines go up to 7 already. We're starting at the 0, we're going up to 7. So we're not sure what to do yet if we're just looking at that first part. But then it says -8. And remember, whenever we have a minus or a negative, we're going to go to the left. All right, so now we want a line that goes back. These ones right here keep going to the right. So I know that it's not B or C. All right, but A and D have lines that go to the left. So we need to make sure we're going to the left 8 spots. So we go 1, 2, 3, 4, 5, 6, 7, 8. So that one looks like it. Let's see if this one only goes back 1, 2, 3, 4, 5, 6, 7. So we know it's not that one. Let me clear out all this so you can see the number line to draw that on your answer sheet for the reflection page. All right, so here is what you will put as your work to show the number line. And then remember what we said, where it ends is our answer. So you would put that 7, and we want to put it in an additive inverse, which means we want an addition sign. So we're going to put a little plus sign in there and make that minus a -8. Remember, a minus and a negative are the same thing. So if we just add that little plus sign, no biggie. And then our answer would be -1. That's where we ended up on the number line. Make sure I didn't skip a page here. Yep. All right, the next thing we're going to talk about is absolute value. Absolute value just means the distance from 0 on a number line. So it will always be a positive result. Okay? If I have a -3, it's still 3 units away from that 0. So it's still going to be a positive 3. And again, if I had a positive 4, well, that's still 4 units away from the 0. So we use that to help us figure out distances between numbers, maybe that are negative and positive. So this little problem here says use the absolute value to express the difference between -10 and 16. So let's figure out the absolute value for each of these numbers. Absolute value goes between these little lines here. I'm going to make those a little darker so you can see that that's not just a 1. All right, so the absolute value of -10. Well, a -10 would just be 10 units away from the 0, so it'd still be a positive 10. And the difference between, the absolute value of a positive 16 would go way out here. It would be 16 units away from the 0. So now to figure out the difference between way over here and way over here, we're going to add those together. So we would just take 10 plus 16, which equals 26. So our difference would be 26. These little notes here are just some ways that you can help remember how to add integers using a number line or just with this silly song that I always sing. And if you come to in-house, you'll probably sing this more than once or hear me sing it if you don't want to sing along. But this would be a good screen to take your snipping tool and save this and print it out, put it in your notes, or just write this down in your notes. This here is just showing you again what we just did with the number line. If we want to use number lines to be able to solve our work, that's fine too. We'd start at 0, and it says -3, so they went back to -3, and then they added a -2, so they still went to the left 2 more, and they ended on that -5. All right, this is what I use to add and subtract integers every time. I know it says adding integers, but you can always change an adding sign or a subtraction problem to an addition problem. So you can always use the song when adding or subtracting integers. It goes like this. Same signs add and keep, different signs subtract. Keep the sign of the higher number, then it'll be exact. All right, I'll explain how that works on the next slide here. So we're going to do a whole bunch of problems. At this point, if you want to pause your video and write down these and try them on your own, that'd be great, and then you can watch it and check it, or just follow along. All right, this first problem right here is a minus. We don't want to have any minuses. We want to have them all positives. Whenever you have a minus and a negative, I like to write it like that so I can see how this will work here. Let me get a different color to show you what happens. When we have a minus and a negative, it makes a positive. So what we do is we just change this to a big plus sign, and that gets rid of that minus and negative. So right here I can just make that into a plus sign. Okay, it's kind of like when you say 2 wrongs don't make a right. In this case, 2 wrongs make a positive, or 2 negatives make a positive. All right, so this first one says 3 plus 5, which is 8. Number 2 should be easy enough for you. It's just both positive numbers, so 8 plus 7 is 15. Okay, now we're going to use that song. We've got different signs. This 15 is positive because there's nothing in front of it. The 8 is negative. So let's sing the song. Same signs, add and keep. Well, they don't have same signs. Different signs, subtract. So they're different signs, so we're going to take 15 minus 8, which is 7. The last part of the song says, keep the sign of the higher number, then you'll be exact. Okay, now we're just looking at the absolute values of the numbers, or just the numbers themselves, not the signs in front of them. The highest number is 15, and 15 is positive, so my answer will remain positive. Same thing for number 4. Same signs, add and keep, different signs, subtract. We've got different signs. That 5 is positive, the 12 is negative. So we're subtracting. 12 minus 5 is 7. Keep the sign of the higher number. The higher number in this case is 12, which is a negative, so we're going to make our answer negative. Then you'll be exact. Number 5, same signs, add and keep. Hey, this one's an easy one. They're both negative, so we're going to add those numbers together. 2 plus 8 is 10. And keep. Keep means keep the sign that's in front of them. so negative. Number 6, same signs add and keep, different signs subtract. So we're going to subtract the two numbers because one's positive, one's negative. Keep the sign of the higher number. 12 is a higher number, so it is negative. So our answer becomes negative. Number 7, same signs add and keep, different signs subtract. Again, we have different signs. One's positive, one's negative. Keep the sign of the higher number, which is negative. So our answer becomes negative 8. Number 8, you should notice right away is going to be 0 because whenever we have opposites, it makes 0. But let's sing our song just regardless. Same signs add and keep, different signs subtract. So 13 minus 13 would be 0. It doesn't really matter to keep the sign because there's no such thing as a negative 0 or really a positive 0. It's just 0. Okay, here's number 2 that you'll need to put on your reflection sheet. So go ahead and write that problem out on your answer or on your equation. The problem is negative 15 minus 5. Just like up here, we had to change that minus to a positive. In this case, we don't have 2 to make a huge positive symbol, but we can always add in a plus sign. So you're going to have your negative 15, and you're going to put in a little plus sign, and then that minus there just becomes a negative. So we're just going to go like that. Okay, so you can always just add in a plus sign and scoot your little symbol over to make it a negative. So now we have same signs, add and keep. So we have 15 plus 5, which is 20. And then keep means keep it negative. They're both negative, so it's going to stay negative. Rational numbers are using fractions in these two. You should not be scared away from fractions. Remember that they're pretty easy. You just have to do a couple more steps. I know a lot of students get freaked out when they see a fraction, but no fear. The biggest thing when adding or subtracting fractions is you have to have common denominators, which you should know by now. But so we're just going to move this 5 over here because our denominator stays the same. It doesn't change. So just pretend those aren't even there. Now you're really only dealing with 1 plus negative 4. That negative can really go with either of these. We're just going to keep it with the top because we can make our denominators the same that way. All right, so now we're really only working with 1 plus negative 4. Same signs, add and keep, different signs, subtract. We've got different signs here, so we're going to subtract 4 minus 1 is 3. Keep the sign of the higher number, so we have a negative 3. So we're just going to put that up there, and negative 3/5 becomes our answer. Easy peasy, no need to fear about those fractions. The last and final problem we're going to do is your number 3 for your reflection sheet. So go ahead and write that problem out. If you'll remember on the last page, whenever you have a minus and a negative, we're going to make that a big old plus sign. So now we're adding negative 2 1/3 and positive 10 1/6. I like to do around the world so that I can make these improper fractions to work with them a little easier. Around the world, you're going to multiply the first number by the whole number, or the denominator by the whole number, and then you're going to add the numerator. And then your denominator just stays the same. So we have 3 times 2. And we're gonna forget about that negative symbol for right now. Just don't worry about that at this point. We'll come back to that at the end. So we're going to have 3 times 2, which is 6, plus the 1 is 7. So we have 7, and our denominator stays the same. So 7/3, and we're saying plus, and here we're going to multiply 10 times 6 and add the 1. So we have 60, 10 times 6 is 60, plus the 1 is 61, and we're going to keep our denominator the same. Now, I want to go ahead and bring down that negative symbol over here. Okay, now before I even add up, I want to think about what my symbol is going to be, what my sign is going to be when I add. I have different signs, so I'm going to be subtracting. So we'll come back to that in a minute. I need to get denominators that are the same. So I have to make this denominator a 6 to be the same as that. So what I do to get to that 6 is I'm going to multiply both my numerator and my denominator times 2. So 3 times 2 is 6, and because I have to do whatever I do to the bottom, I have to do the top. So 2 times 7 is 14. So we're going to make that a negative 14/6 plus 61/6. So now back to what I was saying. They're different signs, so I'm going to subtract. Remember, we don't even have to worry about that denominator. Don't let that get a hold of you. We're just going to make that a 6 down here. That just stays the same. So now we really are working with negative 14 plus positive 61. Same signs, add and keep, different signs, subtract. So when we subtract, we get 47. then we're going to keep the sign of the higher number, which is positive. So we are working with a positive 41 or 47/6. We cannot leave our answer in a improper fraction, so we're going to need to divide that out. 6 can go into 47 7 whole times. 6 times 7 is 42. So then you just count up to get up to 47. 42, 43, 44, 45, 46, 47. So we have 5 left over, and we keep our denominator the same. So our answer becomes 7 and 5/6. That came directly from the pretest. On the pretest, when you take when you take the mid-module check. If you don't get them all right, don't fear, but go back and look them over. It's going to really help you for when you get to the test at the end of the module. Guys, if you have any questions, I will be available on Wednesdays during our virtual time if you want to sign on and talk to me then. Otherwise, you can let me know through an email.